So the tips and tricks for warpage analysis and visualization techniques. So the first thing we need to talk about is, where does warpage come from? So ultimately, warpage is defined in Moldex 3D as a variance in shrinkage, or you can think of it like a variance in density across the part geometry. And that's usually caused by a bunch of different issues or a bunch of different characteristics of the plastic or the design itself. So the first thing we're going to go over is part design. We have mold design, process conditions, the PVT, which is a very, very important concept. We're going to get a little bit more in detail into that. Fiber orientation, we'll take a quick look at that. And then finally, residual stress, how the residual stress in the part after the molding process is going to impact post-mold shrinkage and so on. All right, so first of all, starting off with part design, the first thing we need to consider is the thickness distribution. The thickness distribution is always going to influence how the part cools. So if we have a very thick region of our part versus maybe in the same location, but maybe more centralized, maybe there's a little bit of a thicker region, maybe you haven't cored out the part or something like that. The thickness distribution is going to impact the heat transfer from the plastic out to the mold, and that hot material is going to shrink at a different rate than the colder material. It's actually a really simple concept if you think about it. And thickness distribution, if you make your thickness non-uniform, that will actually influence the shrinkage distribution. Like I mentioned just a moment ago, the shrinkage distribution is actually where warpage is defined. So warpage, or a contorting of the part or a modification of the original geometry based on the process conditions, really starts from the part design, from thickness distribution. We can also think of things like wall angle. So if I'm designing two walls that are coming to interface with one another, if I just draw a 90-degree angle at that wall, heat's going to get trapped in that 90-degree angle, and you're not going to be able to get that heat out efficiently without creating some sort of really advanced cooling system, which is all pretty much on the mold designers. So from a part design standpoint, we can make the lives of the mold designers and the process engineers a lot easier if we can kind of think of these things upstream. And then finally, the last thing we will talk about here is gate location.